Hey there, everybody. Okay, so the purpose of this video is to kind of get you looking at the spreadsheet where our data is going to come from. So we're going to look at the data, we're going to understand where the data happens, and then we're also, in addition to that, we're going to build graphs off of this data. I'm going to show you how to do it for the first experiment, which was deal the cards until we got a repeated suit, and then I'm going to have you do the next experiment, which is do the cards until we get all the suits. So let's just, first of all, understand what we're looking at. If you remember back to the experiment we did in the in-class quiz, which was deal cards until we got a repeated suit, the smallest number of cards that took was 2, and the largest number of cards that took was 5. Because you could go like spades, or clubs, or hearts, or you could deal hearts, clubs, spades, diamonds, and then 5th card matched, anything in between. Okay. Now, in order to get the data, I've written these 2 sheets over here. This right here, and you don't actually have to click into this sheet if you don't want to, but I'm going to show you really quickly what's going on. I'm simulating a deck of cards using random numbers right here. There's 52 random numbers in a line right here, okay? And then I'm using some fun Excel commands that I've learned over the years to arrange them by rank and then giving them suits, 1, 2, 3, and 4, which correspond to hearts, diamonds, spades, and clubs. Okay, everything below this is going to look pretty insane, I think, to you. You don't even have to look at it. All you've got to know is this spreadsheet is keeping track of the cards. Every single time you press the F9 button, you're going to see this column. There's going to be a number that changes by 1. So watch this, F9, boop. Notice this went from 2 to 3. That means on that deal, it took 3 cards until we got a repeated suit. I'm going to press it again. Boop. Oh, that one took 5. Boop. That one took 1. Or excuse me, 2. That one also took 2. That one also took 2. That one took 5 again. So you're seeing every time I press the F9 button, it's repeating the trials again. Now you might also notice something else. Every time I press F9, a lot of these numbers over here change. Like a whole bunch of them are changing all at once. And there's a reason for that. Remember, if we test the recycled deck, I'm calling it the recycled deck, that means that there's more than one series of cards we can use in a deck. For example, suppose, I'm going to do it again right now. If I press F9, this only took 3 cards. That means there's now 49 cards left in the deck that we could keep dealing in the recycled deck and trying to get a new repeated suit, and then a new repeated suit, and then a new repeated suit. Hopefully that makes sense. So for every 1 that this goes up, this guy goes up over here between, I don't know, 10 and 20 times. So that's why these numbers here, the total number of trials in this one is so much smaller than the total number of trials in this one. Okay? So what I'm going to do now is I'm going to just hold the F9 button down for a while and let these numbers kind of populate a bit. Okay, I'm going to let them run a little bit, just a little bit. Now, just so you know, while I'm doing this, I'm going to let the F9 button go. I'm going to click over here to cards until all. The other experiment is also happening right here. Just so you know, we're going to get to that one in a second. Okay, but let's look back here. Now, this is an issue. The fact that I've got more trials in the recycled deck than in the fresh deck. I knew that was going to be an issue. So I thought, what's the best way to deal with it? Well, I wanted to graph the results on the same graph, and I didn't want to have to account for this multiple difference here. So what I did instead was I created the percentages. Instead of the counts, the actual percentage. So for example, of the 363 trials I've run for the fresh deck, 88 of the 363 ended in 2 cards. Well, this simply tells me that's about 24.3%. 3 cards is about 34.5. Now, some of you might be having a hard time seeing this and being like, my God, this doesn't make any sense. So here's a quick, we learned this in class, we'll show it to you again. If you highlight these numbers, and you know what, while we're at it, we'll highlight these numbers too, and then press the percent button up here, it'll change into percentages, and I'll give you a 1 decimal place if you want 1 decimal place of accuracy. Okay, now these ones down here are also sums. So if that represents these numbers here summed up. Now, a quick look up top will tell you that these numbers don't add to exactly 100. These add to 100.3, and these here add to 100, also 100.3. The rounding error is due to the fact that these things are there's a mathematical error that I can't quite pinpoint, but also B, it's a rounding error. Don't worry, it's close enough to 100%, and the more trials you run, the closer it will get to perfectly 100%. That little mathematical error I mentioned before won't matter. So what I want you to do right now is make sure you've got, I'm going to say a weird statistical term here, get a few trials done. Get a few trials done. And make sure that your spreadsheet is up and ready to go before we do the next video, which actually shows you how to get some graphs out of this data. Okay, so we'll stop there, and the next video will show you how to do the graphs. All right.